Hey my amazing students, we're going to be working on our note page 10 today, and I will give you a heads up that this note page is probably one of the harder note pages that you're going to be seeing in this unit. It's because it's on properties of logarithms, and if you don't have a solid foundation on properties of exponents, properties of logarithms tend to be a little bit more difficult. So if you can pause the video and write down one thing that you notice or wonder about these statements, that would be great. All right, so some things that you might have noticed or wondered is you might have noticed, like, how did this statement go to this fraction? Maybe you noticed that if you reduced 27 over 81, you got 1/3. Maybe you realized, oh, once it's in this property right here, then I'm going to be evaluating it, and then you can move the base over to get to the power of x and solve. So really what we're going to be tackling for today is this first step. How do we get from the stage of something like an expression or an equation into something that's a single logarithm? And what we're going to be doing is we're going to be using these properties that are below on the page, and there are 5 of them that are really important. The 2 that you're going to use the most is the product property and the quotient property. We do use the remaining 3 quite a bit, but if you have a solid foundation on the product and the quotient, you should be in good hands as far as logs of properties go. So basically what you need to know about the properties of logs is that these are interchangeable. So what it's saying is if you have a single log with 2 things being multiplied together, you can expand it into them being separate. So notice that you have an m here and an m here, and then you have your n on the second part. What we're going to be using is mainly the reverse, where we take something that has 2 and we put them together. So anytime you see the addition sign, it will be changing into multiplication, okay? Anytime you see the subtraction sign, then it's going to be moving into division. And it's really important that you understand that the first value that's in the log is going to be on top, and then the second value of the log is going to be on the bottom. So let's look at these first 2 examples in the examples that we have down here, and then we'll move on to the other 3. So example A is a good one of the product property. So you'll notice that it has an addition sign here, just like it has an addition sign here. So what that means is that I can multiply the 1 over 25 and the 625 together to create a single logarithm. So now the reason we can do this is notice that it has also the same base of 5. And so we're going to say, okay, 1 over 25 times 625. And we can kind of merge those together. So when we do this, we end up getting 625 over 25. Okay. And if you don't know what 625 over 25 is, don't worry, not a lot of people do. So let's go ahead and take out our calculator. So 625 divided by 25, we get 25 actually. Okay. So what this allows us to do is it allows us to get to that single log space. Okay. Now, like our example of at the very, very top, you'll notice that once we get to the single log space, then we have to set it equal to x to evaluate it. And that's what we're going to do here. So we're going to set this equal to x, and then to evaluate it, remember we move over our base. So we have 25 is equal to 5 to the power of x. So we say 5 to what power gives me 25, and that happens to be 2. So x here will equal 2. So I know that I think the biggest frustration for my students is they're like, this is a lot of work, Ms. Strickland, for such a silly problem. But this is what we have to do if we, let's say, didn't have a calculator that potentially had the ability to create a base of 5, and we would be using these properties to condense. Okay, so essentially when we take something that is a bigger version of a log, we condense it to simplify it. And so we're going to do the same with with letter D. You'll notice that it's going to be very similar, but this is going to be using the quotient property. Now, how do I know it's using the quotient property? It's because there's a minus sign right here. Okay, so you see the minus sign, and so that means that I'm going to be dividing the 12 and the 3. So I'm going to go ahead and highlight the 12 and the 3 for you. Okay, so I'm going to highlight the 12 and the 3. So it's going to be log with a base of 4, and then remember the first number always goes on top, and then over 3. So we end up having log 4, 12 divided by 3, hopefully most of you know that, is 4. And then now it's going to be the same kind of process that we did with A, where we're going to evaluate it. So we're going to set it equal to x, bring it over to the base over to be 4 to the power of x, and then we say 4 to what power gives me 4? Well, that's just 1. And so x will equal 1. So we basically condensed our two logs into a single log and then set them equal to x to solve, okay? Now, before we go into the other ones, I want you to know that I want you to kind of glance at letter F. So letter F is an example of where we are using multiple properties. Not only are we using the quotient property and the product property, but we're also using the power property. So I will go over that one once we kind of look at the other different rules before we do that, okay? So the other three rules that we have are the power, equity, and change of base. The power property just states that if you have a number to an exponent, you can move that exponent in front of the log. And the reason why you might possibly want to move it to the front is that, for instance, if you look at letter B, 64 to the third power is a huge number. Could you do 64 to the third power? Absolutely. But the easier thing for us to do would be to move the 3 to the front, so it's going to become 3 log base 4, 64. And then what I can do is I can evaluate what's inside of the log first and then times it by 3. Let me show you what that looks like. So we have 3, and then what's inside, we're going to do kind of the same thing that we did here once we have that single log. So we have log 4, 64 equals x, and then we can move that 4 over. Oops, I'm so sorry, not a log. So you have 64 equals 4 to the power of x. We say 4 to what power gives me 64? That happens to be 3. So then, now that we know that x equals 3, we're just going to multiply that by 3, and so our end result here would be 9. So you'll notice that instead of having us to do 64 to the third power, which would be very hard for us to do on our own, so 64 times 64 times 64, and then we have to think 4 to what power gives me this huge number, I'm able to evaluate the inside portion first and get what that equals, and then times it by 3 to give me my answer. And so it can be really, really kind of nice for you to do. One thing I want to kind of mention is that you just want to be careful, because sometimes a problem similar to E can look like the power property. So a lot of students kind of make the mistake and they say, oh wait, 4 to the power of 5, right? But no, this is just a regular log. So when it says to evaluate log base 4, 5, you're just going to do the exact same procedure that we did at the very beginning without all of the condensing. So there's no condensing that needs to happen here. And so you just now would move the base over, and you say 5 is equal to 4 to the power of what to the x? Now this is obviously going to be a decimal. It's going to be a decimal because of the fact that we know 4 to the first power is 4, and 4 to the second power is 16. So x here will be kind of around 1.1 or 1.2 as far as the answer goes. So just be careful. A problem can look like a power property but not actually be a power property, and so you want to just kind of be careful on that, okay? Now before I go into the equity or the change of base formula, I wanted to look at this version of this one, because now we've covered the quotient, the product, and the power property. And so a lot of my students ask me, well, what do I do first? Usually what you want to do first is you want to condense it into a single logarithm first. And that can be done in a couple different ways. So this right here means that you're going to be dividing, and this right here means you're going to be multiplying. So it's going to look a little bit confusing at first. So if we were to do this, we would have log base 4, and then remember 9 goes on top, okay, over, And then you're going to be multiplying these together, right? So you have 3 times 2 to the third. Okay. Now this is one of those times that since 2 to the third is 8, it's not a huge thing where you have to like, oh, I have to bring the 3 in the front. You could still do that, but it's not going to be an end-all be-all because the number is kind of small. So you don't necessarily have to use the power property if you don't want to, okay? And so now we can do log base 4, and we have 9 over, so 2 to the third power is 8. 8 times 3 is 24, okay? And then we can reduce this because they are both divisible by 3. And then at that point, we can evaluate it from there.